All right, ready for another deep dive? Today, we're going to get into something you literally can't live without.
Oh, this is a good one. I love this topic.
How your kidneys handle electrolytes. We're talking chloride, bicarbonate, super important potassium, and calcium and phosphate, too.
A lot of moving parts there.
We've got an awesome guide for this journey, a physiology handout from the brilliant Dr. Rasha Eldeeb, an expert in medical physiology. So by the end of this deep dive, you'll not only know how these electrolytes flow through your kidneys, but why it all matters for your everyday health.
It's more connected than a lot of people think.
And we might uncover some surprising links to things like acid-base balance, even insulin. Get ready for some serious aha moments.
Definitely. It's a fascinating system, way more intricate than people realize.
Okay, let's start with chloride. It's often seen as sodium's sidekick, right? Like, they're always together.
Like partners in crime.
But our handout suggests the kidneys don't always treat them equally.
Interesting.
That's the story there.
You've hit a key point. While about 99% of chloride does passively follow sodium during reabsorption, like you said, they're usually together.
Yeah.
But things get interesting in the thick ascending loop of Henle.
Ooh, the loop of Henle.
There, we find an active transport mechanism specifically for chloride.
Specifically for chloride.
Yeah, it's like a dedicated express lane, making sure chloride gets where it needs to go.
Okay, so why the special treatment? What makes chloride so important to have its own transport system?
Well, think of it this way.
I'm ready.
That active transport is crucial for setting up what we call a concentration gradient in the kidney, basically creating a difference in the concentration of substances between two areas.
Okay.
And this gradient, that's the driving force behind your kidney's ability to reabsorb water and other vital substances.
So this chloride express lane, it's not just about chloride itself.
Right.
It's about setting the stage for the whole filtration process to work.
Exactly.
That's pretty clever.
The body is pretty amazing.
The handout also mentions something about chloride playing a role in acid-base changes. How does that fit in?
That's where chloride's connection to maintaining the right pH balance comes in. If your body's dealing with metabolic alkalosis, meaning too much bicarbonate, your kidneys actually start dumping chloride to compensate. Yeah. And the opposite happens in acidosis when bicarbonate is low on. Kidneys cling on to chloride.
They're like little chloride hoarders.
In a way.
Yeah.
It's a constant balancing act to keep everything in check.
That makes sense. So it's not just about keeping electrolytes in balance, but also making sure your body's pH stays within a healthy range. So we touched on how chloride helps regulate pH. Let's move on to another big player in that system.
Let's do it.
Bicarbonate. It's known as the pH buffer superstar.
Catchy name.
But why is it so important that our kidneys reabsorb like over 99% of it? Mostly in the proximal convoluted tubule, as the handout says?
Well, bicarbonate is absolutely essential for buffering acids in your blood, keeping your pH right where it needs to be. Losing too much bicarbonate would make your blood too acidic, leading to acidosis, which can have a cascade of negative effects.
Acidosis, bad news.
Not good.
We know from the handout that acidosis can mess with other electrolytes like potassium. But before we jump to potassium, I'm curious about something. If almost all bicarbonate is reabsorbed, does that mean our kidneys don't have much control over its levels?
That's a great question. While reabsorption is high, our kidneys can still fine-tune things based on your body's needs. Think back to chloride. In alkalosis, when your blood is too basic, your kidneys will actually excrete more bicarbonate to lower the pH.
To get it back in balance.
Exactly. The opposite happens in acidosis. More bicarbonate is reabsorbed to raise the pH. It's a remarkably dynamic system.
Wow. So even though reabsorption is high, the kidneys still have some tricks up their sleeve to adjust bicarbonate levels and maintain that crucial pH balance. Okay, I think it's time we tackled potassium.
Let's tackle it.
This electrolyte is essential for a ton of bodily functions. But what really stood out in the handout was its close relationship with insulin.
Insulin, yes.
Can you unpack that a bit for us?
It's fascinating. High potassium levels actually stimulate the release of insulin, which in turn helps move potassium into your cells. It's a feedback loop designed to keep everything balanced. This is why insulin treatment for diabetic acidosis can sometimes lead to low potassium. It's being shifted from your blood into those cells at a faster rate than normal.
Hold on, so you're saying that giving insulin, which is meant to help control blood sugar, can actually cause potassium levels to drop too low?
It can.
That sounds a little risky.
It highlights the need for careful monitoring. While insulin is essential for managing diabetic acidosis, Healthcare providers need to be very aware of this potential side effect and adjust treatment accordingly to prevent potassium from dropping too low. It's a delicate balancing act for sure.
I see. So understanding this potassium-insulin connection, super important for folks managing diabetes.
Absolutely.
Now, the handout also hinted at a link between potassium and, you guessed it, acid-base balance. Can you shed some light on that too?
Of course.
Yeah.
Acidosis, which we've talked about, can actually force potassium out of your cells and into the bloodstream.
Pushing it out.
Yeah. This can lead to high potassium levels in your blood, even if your total body potassium isn't actually high. It's all about where the potassium is located.
Yeah.
And, as you might expect, the opposite happens in alkalosis.
So once again, pH plays a crucial role in how electrolytes are handled, even affecting their distribution within our bodies.
It's all connected.
This is incredibly intricate. Now, let's switch gears and talk about calcium, the mineral we usually associate with strong bones. But what caught my eye in the handout was the fact that only a portion of it actually gets filtered by the kidneys. Why is that?
You're right. About 60% of calcium is bound to proteins in the blood, making it too large to be filtered. Only the remaining 40%, known as ionized calcium, is small enough to pass through the filtration barrier in the kidneys. And even then, a whopping 99% of that filtered calcium gets reabsorbed, primarily in the proximal convoluted tubule.
Okay, so we've got this small fraction of calcium actually being filtered and then almost all of it being reabsorbed.
Right.
Clearly, our bodies really want to hang on to calcium.
They do.
The handout also mentioned parathyroid hormone, or PTH, as being involved here. What's its role in all of this?
PTH. It's like calcium's personal bodyguard, ensuring it gets where it needs to go. PTH steps in and enhances calcium reabsorption, specifically in the distal convoluted tubule, or DCT. This is one of the key ways our bodies maintain stable calcium levels.
So PTH is making sure we're not losing that precious calcium we worked so hard to reabsorb. It's like double-checking the vault before closing it for the night.
Good analogy.
And finally, we arrive at phosphate, which is vital for energy production and even helps with pH buffering. However, it seems like PTH plays a different role here compared to its interactions with calcium. Can you explain why?
That's an excellent observation. While PTH boosts calcium reabsorption, it actually decreases phosphate reabsorption in the PCT. Remember how I said our bodies are incredibly good at maintaining balance? Well, this is a prime example. While calcium is vital, too much phosphate in the blood can be harmful. By decreasing phosphate reabsorption, PTH helps keep those levels in check.
So it's like PTH is playing a delicate balancing act, ensuring we have enough calcium while also preventing phosphate from getting out of control. It's incredible how our bodies can manage these competing demands.
It truly is. And this highlights an important point. When we think about electrolyte balance, it's not just about making sure we have enough of each one. It's about maintaining the right proportions and making sure they're all working in harmony.
That's a really key takeaway. It's not just about individual electrolytes. It's about the intricate web of relationships between them. All right, before we dive deeper, I want to pause and ask you, dear listener, what's resonating with you so far? Anything sparking your curiosity or making you see your own health in a new light?
Yeah, take a moment to think about what you've learned and consider how it might impact your understanding of your own body.
We'll be back in a moment to unravel even more about this incredible system. Welcome back. I don't know about you, but I'm already feeling a lot more knowledgeable about what my kidneys are up to.
Right. It's fascinating stuff. The more we understand about these processes, the more we appreciate the incredible complexity of our bodies.
Absolutely. Let's dive a bit deeper into some of the factors that can influence how our kidneys handle these electrolytes. We've talked about acid-base balance.
Right.
But what about things like our diet or the medications we take? Can those have an impact?
Definitely. What we eat and drink can significantly influence our electrolyte levels. For example, a diet heavy in processed foods, those tend to be loaded with sodium, can lead to increased chloride reabsorption.
That makes sense. Sodium and chloride, always hanging out. Speaking of diet, what about potassium? What are some good sources of that?
Fruits and vegetables are your best bet when it comes to potassium. Think bananas, avocados, spinach, sweet potatoes. They're all packed with it.
So a diet rich in fruits and veggies, good for potassium levels.
Totally.
But it's not just about what we eat, right? Staying hydrated is important too.
Absolutely. Dehydration can throw your electrolytes out of whack, leading to things like high sodium and chloride levels. Think of it this way. When you're dehydrated, your body is trying to hold on to as much water as possible. and that means holding on to those electrolytes too.
So drinking enough water, crucial not just for overall health, but for maintaining that delicate electrolyte balance. What about medications? Can those affect things too?
Certainly. Some medications like diuretics, which are often prescribed for high blood pressure, can increase potassium excretion,
Oh,
potentially leading to low potassium levels. We call that hypokalemia.
hypokalemia. So it's important to be aware of potential side effects and to work closely with your doctor to manage any risks associated with certain medications. That brings us to another point I wanted to touch on, the clinical implications of electrolyte imbalances.
Yeah.
What kind of symptoms might someone experience if their electrolytes are off?
Electrolyte imbalances can manifest in a variety of ways. You might experience muscle weakness, fatigue, confusion, even an irregular heartbeat. In severe cases, seizures are even a possibility.
Wow, those are some serious symptoms. It's amazing how these tiny electrolytes can have such a profound impact on our overall health. What can be done to address these imbalances?
Treatment typically involves addressing the underlying cause of the imbalance. This might mean making dietary changes, adjusting medications, or even receiving intravenous fluids to replenish electrolytes.
So it's a personalized approach based on the individual's needs and the specific imbalance they're dealing with. Now, before we move on, I want to circle back to something that really caught my attention, the connection between potassium and insulin.
Right.
You mentioned how insulin treatment for diabetic acidosis can sometimes lead to low potassium. Can you walk us through exactly how that happens?
Of course. When insulin is given, it doesn't just help move glucose into cells for energy. It also encourages potassium to move into cells as well. This is normally a good thing, helping to maintain potassium balance.
Right.
However, in someone with diabetic acidosis where potassium levels might already be high, this insulin-induced shift of potassium into cells can cause those levels to drop too low, potentially leading to hypokalemia.
So it's like insulin is a bit overzealous in its potassium-moving duties in those situations.
You could say that.
What can be done to prevent this from happening?
Careful monitoring is key. Healthcare providers need to be aware of this potential side effect and closely monitor potassium levels in patients receiving insulin, especially for those with diabetic acidosis. They might adjust the insulin dosage or even administer potassium supplements to prevent levels from dropping too low.
It sounds like a delicate balancing act requiring a lot of expertise from the healthcare team. That said, I'm starting to see a pattern here. Potassium seems to be particularly sensitive to changes in pH and insulin levels. Is that accurate?
We're spot on. Potassium regulation is intricately linked to both acid-base balance and insulin activity. That's why understanding those connections is so crucial, particularly for individuals with diabetes.
It really highlights the importance of taking a holistic approach to health, looking at the bigger picture and understanding how different systems interact with each other. Now, let's shift our focus back to calcium for a moment. The handout mentioned that parathyroid hormone, or PTH, enhances calcium reabsorption in the distal convoluted tubule. I remember you comparing PTH to calcium's bodyguard.
I did.
But can you explain exactly how it manages to pull off this feat? Does it have special powers or something?
Well, PTH does have some pretty impressive tricks up its sleeve. One way it enhances calcium reabsorption is by increasing the number of calcium channels in the cells of the DCT.
Okay.
Think of these channels as doors that allow calcium to pass back into the bloodstream. More doors mean more calcium can be reabsorbed.
So PTH is basically building extra doorways for calcium to sneak back in. That's pretty cool.
It is. But PTH doesn't stop there. It also stimulates the production of a special protein that binds to calcium, helping to escort it across the cell membrane and back into the bloodstream. It's like a VIP service for calcium reabsorption.
Wow, so PTH is not just a bodyguard, it's also a master architect and a chauffeur. It really pulls out all the stops to ensure we're holding on to that calcium. Now, I remember you saying that PTH actually decreases phosphate reabsorption. Why is that? Wouldn't it make sense for it to boost the reabsorption of both calcium and phosphate since they both contribute to bone health?
That's a great question. And it gets back to that concept of balance we've been talking about. While calcium is essential, high levels of phosphate in the blood can actually be harmful, potentially leading to issues like calcium deposits in soft tissues and even cardiovascular problems.
Oh, wow.
By decreasing phosphate reabsorption, PTH helps keep phosphate levels in check and prevents those negative consequences.
So it's like PTH is playing a delicate balancing act, ensuring we have enough calcium while also preventing phosphate from getting out of control. It's incredible how our bodies can manage these competing demands.
It truly is. And this highlights an important point. When we think about electrolyte balance, it's not just about making sure we have enough of each one. It's about maintaining the right proportions and making sure they're all working in harmony.
That's a really key takeaway. It's not just about individual electrolytes, it's about the intricate web of relationships between them. All right, before we wrap up this part of our deep dive, I want to turn things over to you, dear listener. We've covered a lot of ground here. From the specific mechanisms of electrolyte handling to the influence of diet and medication. What's sticking with you the most? What new insights have you gained about your own health and how your body functions?
Yeah, take a moment to reflect on what you've learned and consider any questions that have come up for you. We'll be back soon to explore even more fascinating aspects of this incredible system.
Welcome back to our deep dive into electrolytes in the kidneys. It's amazing all these intricate mechanisms we've uncovered.
It really is a symphony of processes, isn't it?
Each element playing its part to keep everything balanced. You know, one thing that struck me is how interconnected everything is. It's not just about individual electrolytes.
No.
It's about how they all relate to each other.
Precisely. A shift in one can trigger all these effects on others. We saw how acid-base balance influences potassium, chloride.
Right.
And don't forget that interplay between potassium and insulin, especially for people managing diabetes.
And then there's PTH, the multi-talented hormone regulating calcium and phosphate, like a master conductor, making sure the whole orchestra is in tune.
A great analogy. It's a beautiful illustration of how our bodies strive for that harmony.
But what happens when this balance is disrupted? We touched on the symptoms of electrolyte imbalances, but what about the bigger picture? What kind of domino effect can these imbalances trigger?
Well, electrolyte imbalances can have far-reaching consequences, impacting systems throughout the body. For example, potassium imbalances can disrupt heart rhythm, leading to arrhythmias.
Okay.
Calcium imbalances can affect muscle function, nerve transmission, even bone health. And phosphate imbalances, those can contribute to bone disorders and mineral metabolism issues.
So it's not just about feeling tired or having muscle cramps. These imbalances can have serious long-term consequences if they're not addressed.
Exactly.
It really makes you realize how important it is to pay attention to our electrolyte levels and get medical attention if something feels off.
Absolutely. Early detection and intervention are key to preventing those cascading effects and maintaining overall well-being.
Now, before we wrap up this deep dive, I want to touch on something we talked about before, the influence of lifestyle choices on electrolyte balance.
Oh yeah, good point.
Can you elaborate on how factors like diet, hydration, exercise can impact these delicate systems?
Sure. Our daily habits play a big role in maintaining that balance. Like we mentioned, a diet rich in processed foods, which tend to be high in sodium, that can lead to increased chloride reabsorption and potentially disrupt the balance.
So choosing whole, unprocessed foods is a good step.
Definitely.
What about hydration?
Staying adequately hydrated is crucial for maintaining proper fluid balance, which affects electrolyte concentrations.
Right.
Dehydration can lead to imbalances as the body tries to conserve water and electrolytes.
It's a reminder to listen to our bodies and make sure we're getting enough fluids, especially when we're active or it's hot out. And speaking of exercise, how does that come into play?
Exercise can increase electrolyte loss through sweat, particularly sodium and chloride.
Okay.
That's why it's important to replenish those, especially during prolonged or intense workouts.
So a sports drink or even just adding a pinch of salt to our water can help?
Exactly.
It's fascinating how even those everyday activities can influence the balance within our bodies.
It really highlights that dynamic interplay between our internal systems and external factors, and it emphasizes the importance of making those conscious choices to support our health and well-being.
As we wrap up, I'm struck by how complex yet elegant these renal processes are. It's a testament to how incredible the human body is, its ability to maintain equilibrium in the face of constant change.
It truly is remarkable.
Before we go, what are some key takeaways for our listeners as they continue learning about electrolyte balance and kidney health?
Well, I'd encourage everyone to think about how their lifestyle choices, like what they eat and drink, their hydration, and their exercise habits, how those can impact their electrolyte levels. Be mindful of any medications they're taking and potential interactions with electrolytes, and most importantly, listen to their bodies and seek medical attention if they experience any unusual symptoms.
This deep dive has been an incredible journey through the intricate workings of our kidneys and how they maintain electrolyte balance. We hope you found it enlightening and empowering, giving you a deeper appreciation for the amazing things happening within your own body. Until next time, keep those kidneys happy and hydrated, and stay curious about the incredible world of human biology.